Lesson 94, we're talking about uniform motion problems. Now before, we talked about things going in equal distance and when we made a graph. Today we're also talking about that same concept, but today our graphs look a little bit different. Our graphs are going to look a little bit different. So our problems today are going to come in two forms. If two objects start in the middle and they go in opposite directions, we're talking about how far apart do they end up. Okay, so the old cliched, make you mad at a word, train problem, where they both start in the same place going opposite directions. How far apart do they end up? Or we're talking about problems where one starts in one station and one starts at another station, and they meet in the middle somewhere. Maybe they cross paths. Maybe they have a head-on collision. Hopefully not. But whatever, where do they meet? And it's not necessarily in the middle. They might meet somewhere else. But where do they meet? And that's the first kind of problem that I drew is the one that we're going to start with first. And again, what do? Substitution and elimination to solve these problems. That's it. But our goal today is to plug in the information, knowing what's that magic formula that's going to help us solve these problems. D equals RT. Knowing that we can also substitute rate times time for D because they equal each other. Being able to do that is what is going to allow us to solve these problems. So let's take a look at the first type. If a southbound bus going south, left Fort Walton Beach at 9 a.m., that's our time. 2 hours later, a northbound bus left the same station. Okay, did they leave at the same time? No. If the buses traveled the same rate, they're going the same speed, and we're 352 kilometers apart at 2 p.m., find the rate of the buses. So we have to figure out, first off, the time for the northbound and the time for the southbound. Okay, 2 p.m. is our magic number, right? I said the northbound bus left 2 hours after 9 a.m., which would be it left at 11. How many hours is it between 11 a.m. and 2 p.m.? Do that in your head. No, 3. So northbound bus is 3 hours. What's the time for the southbound bus? 9 a.m. to 2 p.m. 5 hours. We were also told that the rate of the two buses was exactly the same. Oh, why did I write T? I don't know why I did that. Thank you for correcting me. RN and RS. Their rates are the same. We are told that much information. We were also told how far apart they were, which was 352 miles apart at 2 p.m. Okay, remember distance equals R times T? Correct? All right, so for our equation that we can make with that is 352 equals RS TS plus RN TN. Because it's their two distances together that can help us figure out this problem. Okay, so what can we substitute? Well, we can substitute time for where it belongs, and we need to find the rate for either the southbound or northbound. It doesn't matter because they're the same. So let's substitute something. What do you want to solve for? N or S? I don't care. N. Okay, so now we get 352 equals Rn. I substituted that for the time 3 or 3Rn plus Rn times 5. Substitute the time. So 5 RN plus 3 RN is 8 RN. And 352 divided by 8 is 44. And because I had originally said we were dealing with kilometers, that's kilometers per hour. That's their rate. And that was easy for us to substitute that information into, isn't it? Wasn't hard at all, since the two rates were the same. Knowing that information made our life simple. So let's look at the second type. What happens when they meet in the middle? What happens when they meet in the middle? A train starts from Toledo. There's a cliche problem. Toledo, Ohio, at 11 a.m. Holy Toledo. And heads for Mackinac, 332 kilometers away. At the same time, a train leaves Mackinac and heads for Toledo at 65 kilometers per hour. If the trains meet at 1 p.m., don't get lost. What is the rate of the first train? It's in your book. All right. Do they both travel the same distance? Yeah, because we're doing equal distance problems still. So distance 1 plus distance 2 equals 332, right? Which is why we're able to substitute in the rate times time for distance. So that means we can do R1 T1 plus R2 T2 equals 332. We're able to substitute that information in for what we have. That allows us to do that. What is their time? They both left at 11. They get to where they're supposed to be at 1 o'clock. What's their time? They're both 2. So T1 equals 2 and T2 equals 2. 2 hours. And we know the rate of one of them, 65 kph, which was the second one. Okay, so we know all that information. Since we know all that information, we are free to substitute. All right, so we're going to write 2R1 plus 65 times 2 equals 332. We only have one variable, right? Because I knew both variables for the second one. First one, we knew one of the variables. All right, 65 times 2 is 130, correct? Okay, so 2R1 plus 130 equals 332. 332. That's 2R1 equals, what's 332 minus 130? 202. Okay, so R1 is, what's the rate?
101.
101 kph, kilometers per hour. Okay, they told me the rate of the first train. We knew the second train. All we had to do was find the first one. Okay, one more way these are going to show, and these are again the meeting in the middle deal. What happens when they meet in the middle? Two ships were 400 miles apart at midnight. Okay, so if I were to graph that out, here's my two ships, and they were 400 miles apart. And we're headed directly toward each other. If they collided at 8 a.m., find the speed of both ships if one was 20 miles per hour faster than the other one. All right, so let's talk about the distance problem first. The distance of the faster one plus the distance of the slower one equals 400, so that's how far apart they were, right? And if I substitute all that stuff in, RF times TF plus RS times TS equals 400. Substituted all that in. how long was it till they collided? Midnight to 8 a.m. was what? How many hours is that? Okay, 8 hours for both of them. And we also know one more piece of information. Faster one was how much faster? RF equals RS plus 20. Right? Now we plug it in. So, what would be the best way to plug in our information? I substitute RF for RS plus 20. I could figure that out to be 8RS plus 20 times 8, which is 160 equals, or sorry, plus RS times 8. So 8RS equals 400. Got it so far? So 16RS equals 240? 240? RS equals? What do you say? RS equals?
No.
Not 20. What's 240 divided by 16? 15 miles per hour. That means the faster one is 35 miles per hour. Right? It means they would not meet in the middle. They'd meet, faster one would be further than the slower one before they hit total distance travel. These are just like the other problems.
Yeah, they don't seem any different.
They're not any different in setup. They're different in wording of the word problem.
That's what it is.
That's the only difference. But we're not doing anything different today than we did on Thursday. There's no difference in this problem
Are we going to have a test?
on Friday.
Friday.
Everyone's going to test on Friday.
Can you test?
Huh? No.
Why
One
come we
test.
didn't have a test last week?
My decision. Everyone's going to test on Friday. All right, does that make sense? Okay, so that's what we are that's what you are doing. Okay? This is not new.